All right, in this video I'm going to show you how to fill in this trig table without a calculator. So we have to first interpret what the table is asking us to do. Across the top row we have this symbol theta, which means any angle. And then across that row we have pi over 6, pi over 4, and pi over 3. The first point of confusion is what those mean. And in fact, those are just different ways of writing three very commonly used angles in trigonometry. So those are actually angles up there across the top. Pi, when you're talking about radian measure for an angle, is equivalent to 180 degrees. So I think about pi as like half of a circle. So pi, when I divide it by 6, is like 180 degrees divided by 6. And so that's talking about the angle of 30 degrees. Pi divided by 4 is like 180 degrees over 4. And so that's 45 degrees. And pi over 3 is 180 degrees divided by 3, which is 60. So across the top, really, we just have 30 degrees, 45 degrees, and 60 degrees written in a different unit, which is called radians. You're not going to do anything with the pi over 6, pi over 4, pi over 3. That's just so you know which angle, a 30 degree or 45 degree or 60 degree angle, you are then going to be finding the sine, cosine, tangent of, and these other trig ratios as well. So these are the three most commonly used acute angles in trig, 30, 45, and 60. And there are two triangles, a 45, 45, 90 triangle, and a 30, 60, 90 triangle, which have ratios you should more or less memorize. Fix the end of that. So in a 45, 45, 90 triangle, two of the angles are the same. The 90 degree angle is here. No matter what the sides are, if I put opposite over adjacent, let's say, that's going to reduce to the same ratio no matter how long or how large the triangle actually is. So I can pretend that this length is 1, which means this length will also be 1. And if I'm doing something like the tangent of 45, let's just use that as an example. The tangent of 45 from our SOHCAHTOA, if I write that out as well, we're going to use that to fill in our table. So SOHCAHTOA. Tangent of 45 degrees is talking about the opposite over the adjacent. So opposite would be 1, adjacent would be 1. Now, I chose 1 and 1, but I could have just as easily used 5 and 5 or 13 and 13. But no matter what, when I create a ratio of them, that ratio is going to reduce to the same thing. So we might as well just use 1. It's the easiest number. So we're going to use 1 and 1. And then if I was to actually work out the whole Pythagorean theorem to figure out this hypotenuse, I would find out that it's the square root of 2. So henceforth, you should just remember that you can always draw a 45, 45, 90 triangle with the sides labeled 1, 1, and the square root of 2. I'm just going to clean up this triangle here. So 45, 45, 90, 1, 1, root 2. You should get good at drawing that triangle for yourself very quickly. In this other triangle, the two of the acute angles are not the same anymore. One of them is smaller than the other. This one's 30. This one is 60. That sum is still 180. And again, I'm going to choose to label the sides with what I think of as the easiest number, 1. I'm going to put 1 on the shortest side. The shortest side is across from the smallest angle, which is the 30. And then we can memorize that the hypotenuse of a triangle that's got 30, 60, 90 is always double the short leg. So here it'll be 2. And then the other side, the medium-sized leg, is the square root of 3. So we should get very good at drawing these two triangles, and then we're going to base the entire rest of the table off of the two triangles we have drawn. So in this cell of the table right here, I'm asked to find the sine of 30. I'm reading it like this, sine of 30 degrees. So I go to my triangle that has 30-degree angle in it, which is over here, and I'm talking about sine. So I'm going to do opposite over hypotenuse and set up that ratio, which here is 1 over 2. I'm going to continue down this column while I'm looking at the 30-degree angle that I have marked in red. I'm next going to do cosine of that angle. Cosine is adjacent over hypotenuse. I get that from SOHCAHTOA. Adjacent over hypotenuse is going to be the root 3 over the 2. And that's how we're going to fill in the rest of this table, one step at a time using each angle that I've got indicated across the top. So tangent is opposite over adjacent. I'm going to go to my 30 degrees. Opposite is the 1, and adjacent is the root 3. So 1 over root 3. But we don't leave answers like that because we don't like to have radicals in the denominator. So in fact, we write our answer as root 3 over 3. Then the next three trig functions, cosecant, secant, and cotangent, are just the reciprocals of the three we've just done in that order. So if I'm going to just flip upside down each of the fractions I just wrote, then 1 over 2 becomes 2 over 1, which is just 2. Root 3 over 2 becomes 2 over root 3, but we don't like to write our final answers with radicals on the denominator, so the numerator becomes 2 root 3, and the denominator becomes rationalized. And then the reciprocal of tangent becomes cotangent, and so that's just going to be root 3 over 1. All right, so there's our 30-degree angle. We did sine, cosine, and tangent using our triangle. Then we flipped to get the cosecant, secant, and cotangent. For a 45-degree angle, we're going to head over to the 45, 45, 90 triangle, pick out one of those 45-degree angles. Doesn't matter which, we'll get the same answers, and start doing SOHCAHTOA. So the sine of 45 is opposite over hypotenuse, which is 1 over root 2. But we don't write our answers with radicals in the denominator, so root 2 over 2. Cosine ends up being the exact same thing. Adjacent over hypotenuse is also root 2 over 2. And the tangent we talked about before is 1 over 1. Then when I do the reciprocal of these, the reciprocals of these, it's root 2, and the reciprocal of 1 is just 1. And then finally, I'm at the 60-degree angle. Go back to the 30, 60, 90 triangle and start doing SOHCAHTOA from there. So sine of 60 is going to be opposite over hypotenuse, which is root 3 over 2. Gotta change colors. Root 3 over 2. The cosine of 60 is adjacent over hypotenuse, so 1/2. The tangent is opposite over adjacent, so root 3 over 1. And then I'm just going to do the reciprocals of these in the same order. And I've filled in my table. So really we're just talking about finding sine, cosine, and tangent using SOHCAHTOA from two triangles that you're supposed to have memorized so that you can always set up the ratios with the easiest possible numbers and then set up the sine, cos, and tan. The other three are just the flipped upside down versions of those. That's all.